Okay, here we go. We're going to try example 2. It says, let R be the region in the first quadrant bounded by these two equations. It says that region R is the base of a solid, so that means from the top view, I'm looking at this white space that's enclosed labeled R, and then it tells me the cross sections are perpendicular to the y-axis, and they're rectangles whose height is 2 times the length of the base. So let's see my beautiful drawing. By the way, sorry for the spill right there. Okay, so if we come over here and we're looking at it from this angle, notice that it's a series of rectangles where the base is on the paper and the height for each rectangle is twice what's on the base. So I have a series of those on my paper. I always like to see when students do this activity to see if they can get this one standing up. I didn't really help my cause by, spilling pomegranate polar seltzer water all over it. But yeah, here we go. We have this guy right there, okay? So let's come back to this problem and see, do we remember how to attack it? First of all, I'm asked to find the volume. That's the antiderivative of the area. The area of what? Well, it told you find the area of a rectangle, and we know the area of a rectangle is the base times the height. But what was special about it in this problem? Well, it told me that the height is 2 times the length of its base. So instead of writing base times height, the height is 2 times the base. In other words, h equals 2b. So instead of writing the area equals base times height, we can say the area equals base times 2 times base, which is 2b squared. Okay, so that's our first trick, is to get it down to one variable. Now we have to figure out, well, how do we find the base? So there's 2 very important things here. First of all, it told us that the base is perpendicular to the y-axis. So if you remember when we were talking about this, perpendicular to the y-axis means you need to do a right minus a left equation. So you have to do x equals equation and the y values for the limit of an integral. So let's go over here. The equation on the right-hand side of my base is y equals 2 root x, but I need to get that in x equals form. So I'm going to divide by the 2, and then I'm going to square both sides. So I get y squared 4 equals 0. So the right side of my base is this equation. The left side of my base is this equation. And what equation is that? You can see I spilled my seltzer water here, but this equation is x equals 0. So notice I drew these lines from one side of the shape to the other because it told me perpendicular to the y-axis. So notice how I'm drawing from one side to the other side, perpendicular to the y-axis. I always like doing this because it shows me the right equation is what this side is touching, y equals 2 root x, or rather x equals y squared 4, and the left side of my line is touching this line, x equals 0. Okay, so what does that mean? Well, that means my base is the right equation minus the left equation. Sorry for the shadows, I'm not Steven Spielberg. So the right equation was y squared over 4, and the left equation was x equals 0. So my base is y squared over 4 minus 0. If you don't want to write this 0, you don't have to. I just like to show where it comes from. So when I go ahead and write and solve my equation, I say the volume equals the antiderivative of the area. We said the area was 2b squared. What was the base? It was the right equation minus the left equation, y squared over 4 minus 0. And remember, when we're doing a right minus left, we need the lowest value on the y side to the highest value. So we look over here, the lowest value is 0, the highest value is 6. We put that in our calculator and we get our answer. So again, figure out the shape, figure out what makes that shape special and get it down to one variable. Figure out if it's perpendicular to the y-axis or the x-axis. This example was perpendicular to the y. Figure out what your base is, put it in the equation, get your answer. That's example 2.